Hey, welcome back to Jed Foster Maths, and in this video we're going to be talking about differentiation, and this is a follow-on from the last video, which was the basic introduction to differentiation. And before I start, I just encourage you, if you're not familiar with this, make sure you watch the previous video and come to this. So regarding the chain rule, this is what we're moving on to. And what the chain rule does for differentiation is, let's say if we were given a function of 5x squared minus 10, and this is all to the power of, we'll just say 3, so it's cubed. And this is where we need to learn, this is where we're going to use the chain rule. Because we have an inner function all to the power of something, and the inner function consists of multiple parts, alright? So without having to expand this out or do anything annoying like that, there's a shortcut to this, and that is the chain rule. And then in this video, I'm going to be showing you the shortcut to the chain rule. In my opinion, this way is a lot easier and nicer to learn, and you can use this for everything, alright? So what the chain rule says is we're going to have our derivative, and I'm going to start writing it as y prime, just because it's a bit easier to write. And in the last video I was writing it as dy dx, y prime. They mean the exact same thing. They are the same thing. So our derivative is going to be equal to, and what the chain rule says is we're going to take the power is cubed, so that's 3. Then we're going to multiply it by the derivative of the inner function. So let's find the derivative of the inner function. We know that's going to be 10x, and the 10 is going to go to 0 because it is a constant. So we're going to have 3 times 10x, and then what the chain rule says next, we need to keep the bracket the same, 5x squared minus 10, and we're going to take 1 from the power, 3 minus 1. This is the chain rule. So what this says is you multiply the power by the derivative of the inner function, so that the inner function is, this is going to be the inner function. So we're finding the derivative of the inner function, which is just 10x. So multiplying that by the power, and then after that we have to multiply it by the function again. But we're not changing the function, we're just leaving it as it is, and then we're taking 1 from the power. So I hope that makes sense, and you're going to need to practice a few of these before you start getting the hang of it. So let's move on to another one. Let's say we had y equals, we're going to say, let's do 2x cubed minus 10x squared plus 7 cos of x. And we're going to raise this to the power of a half. Remember, that's the same as the square root of the function, so it could also look like that. But we're just going to write it as a half. Just know they mean the same thing, so if you ever see a square root, it means the same thing, alright? Okay, so let's take the power out the front, a half. We've taken the power out the front. We're going to be multiplying by the derivative of the inner function. So that's the function in this, inside the brackets. And from the rules that we discussed in the previous video, we're just going to apply those same rules to this, alright? So that's going to be 6, sorry, my tablet's not working, 6x squared minus 20x plus, we're going to have minus 7 sine of x. So that's the derivative of the inner bracket. And then next up, what we need to do, we're going to write the whole function in and leave it the same. We're not going to change anything. We're going to have 2x cubed minus 10x squared plus 7 cos of x. And that's going to be to the power of negative a half, because we are taking 1 from the power. So we can start to expand the brackets. I suggest you expand the first one, and as you're going to notice with our second bracket, that's the negative a half. So with your indices rules, we know that we can bring that down to the denominator, and that's going to be to the power of a positive half. And later on, that's going to allow us to simplify it even further, just to the square root. But we'll get to that. Let's work on expanding the first part of the function. We know a half times 6, half of 6 is going to be 3x squared, a half of 20 minus 10x, and then we're going to have minus 7 on 2 sine of x. And this is where we can bring this down to the denominator, so we can have, remember to bracket the entire thing because this is all to the power of the half. So we're going to have 2x cubed minus 10x squared plus 7 cosine of x. So that y prime, that's going to be our derivative, and we can simplify this down even further. We know our derivative is going to be equal to 3x squared minus 10x minus 7 over 2 sine of x. And notice that's to the power of a half, so that is the exact same as we're taking the square root of the entire function inside the bracket. So that's the same thing. So we're going to have 2x cubed minus 10x squared plus 7 cosine of x. So that's our chain rule. And let's move on. Let's do another example. And for this one, please pause the video. Give this one a go yourself. We're going to have y equals, let's say we're going to have the square root of, let's just say 2x squared plus 3x plus 6. And then we're going to have plus ln of x. Alright, let's move on to this one. So we know our derivative, we know y. And remember what I said before about your square root. This is going to be the exact same as to the power of a half. So we can say our derivative is going to be equal to a half multiplied by the derivative of the inner function. That's going to be 4x plus 3 multiplied by the original function and taking 1 from the power. That's going to be 2x squared plus 3x plus 6 minus a half. And remember from the video before that the derivative of ln x is just 1 over x. So we can simplify this down. We're going to have y prime equals half of 4, 2x plus, we're going to have 3 over 2. And then we can also bring down the this function here to the power of a negative half. We bring it down to the denominator, take it downstairs, that becomes a positive a half, and we know that a positive a half is just the same as square rooting the entire bracket. So that's going to be 2x squared plus 3x plus 6. We're going to square root everything, and then we're going to have plus 1 over x. And that's our basic introduction to the chain rule. And you could also simplify this down even further if you wanted to. We're just going to leave it like this for now, keep things a bit more simple. And let's move on to something else. But just remember, this is what the chain rule is. You're always taking the power, multiplying it out front, and then you're going to multiply it by the derivative of the inner function. Then you're going to write the outer function and then take 1 from the power. And this can apply to many different things. So let's move on to, say we were given y equals we'll say sine of 2x plus 6x squared. This might look a little bit different, but the chain rule remains the same. So when using the chain rule on this function, what we're going to do, we're going to look at the inner bracket. So we're going to take the derivative, we're going to have the derivative is going to be equal to 2 plus 12x. Why is this important? Because what the chain rule says, we're going to take the derivative out the front. We're going to have, let's write it like this, 12x plus 2. And then all we need to do now, we need to write, multiply it by the derivative of the outer function, which is going to be cosine of 2x plus 6x squared. And as you can see, this is the same as your basic chain rule. This is just becoming a little more complicated, but we're applying the same rules. And an easy way to remember this is you're differentiating in, then you're differentiating out. So diff in, and then diff out. And you're differentiating the inner function first, and after that you're differentiating the outer function. So that's how you apply it to a trig function. Exact same would be if you had cosine of x. You'd be doing the same thing. And let's say next up, if we had y equals, I will have ln of, let's say, so we had ln of 2x plus 6x plus, we'll say 2x cubed plus 6x squared. Then we'll just say plus 1. Remember, first what we need to do, we need to diff in. The derivative of the inner function, the function inside these brackets, is going to be equal to 6x squared plus 12x. And the 1's just going to go to 0. And then next up, we're going to differentiate the outer function. And remember the derivative of ln of x equals 1 over x. So the derivative of this function here is just going to be, remember we're multiplying by the outer derivative, that's just going to be 1 over, and then the derivative, 1 over the inner function. That's going to be 2x cubed plus 6x squared plus 1. And we can simplify this down. When we multiply that out, we're going to have 6x squared plus 12x all over 2x cubed plus 6x squared plus 1. So that's the derivative of y equals ln of 2x cubed plus 6x squared plus 1. So step 1, diff in, differentiate the inner function. Step 2, multiply it by the derivative of the outer function. Step 3, simplify, and you've got your answer. Even if you don't simplify, you've still got your answer numerically correct, provided you followed the rules correctly. So make sure you practice these and get the hang of them. Once you do a few chain rule practicing, you'll become much better at these, much more fluent, and you'll be able to do it just at the top of your head. And that's the point that you want to get to. So I just recommend practice a lot of these until you get the hang of them. And let's end the video with y equals, let's say we have ln of cos of 2x squared plus 1. Now this is getting a little more complicated, but we're going to follow the same rules. So step 1, diff in. Sorry. Okay, the derivative of the inner function cos of 2x squared plus 1, we're going to have to use the chain rule a second time. So the derivative of cos of 2x squared plus 1, we know that's going to be 4x times, and the derivative of cos is negative sine x. Okay, so that's the derivative of the inner function, and remember that we had to use the chain rule a second time. I did a very similar example above for a trig function. If you're having trouble with this, go back, watch that example, and then let's move on. And then we need to diff out. And remember, we're multiplying the derivative of the inner function by the outer function. So we can times this and multiply this by, and we know when we're differentiating ln of something, it's just going to be 1 over that something. So we're going to have 1 over cos of 2x squared plus 1. And expand this out, y prime, our derivative is going to be equal to minus 4x sine of 2x squared plus 1, all divided by cosine of 2x squared plus 1. So that's the end of the video, and I hope that you're understanding this and that I'm explaining it well. If you have any comments or anything you'd like me to change in the future, any questions, anything like that, please leave it down below. Just please be positive, and I'd love to help you out as much as I can. And always remember that Jesus loves you, and I love you too. Have a great day. Bye.